Integration by substitution. How does this work and when do we use this? Let's go ahead and just solve an example. Let's solve examples. Our first example is we want to take the integral of 10x x squared plus 1 to the power of 4 dx. If you're a good student, a good Calc 1 student, the first thing you will think of is, okay, how about I just expand? Why can't I just expand x squared plus 1 to the power of 4? That's good. You expand it and then you multiply everything by 10x and then you get a polynomial, and that becomes easy to find the antiderivative. But what integration by substitution let us do is simplify this function. The first thing you do is you choose another variable. Usually we call that variable u. All right, in this case, I'm going to choose my u. I'm going to say let my u be equal to x squared plus 1. So if you look at what we have now, the original problem can now be written as 10x times u to the power of 4 dx. It's looking a little bit simpler than 10x times x squared plus 1 to the power of 4 dx. But the problem is that in an integral, two variables cannot coexist. We cannot have u and x at the same time. So what we have to do now is to change everything that's in terms of x to rewrite it in terms of u. So how do we do that? If we have u as x squared plus 1, if we take the derivative of u, let's say du dx, we now get 2x. All right, we're getting somewhere. If we do this, we can now treat du dx as a fraction, and then we can solve for dx. So if we solve for dx, we end up getting that dx is the same thing as du over 2x. So you find your u, you take the derivative, and then you substitute, you look for dx, and then you rewrite dx in terms of du. So this means that our original problem now becomes integral 10x u to the power of 4. Instead of dx, we now have du over 2x. But now look at this. Things are becoming easier because we can now cross things out. If you cross this out, let's cross it out with a tiny green. All right, cross this out. Oh, too tiny. This and that, you get 5, right? All right, so this will now give us 5 integral, oh, I want blue, integral 5u to the power of 4 du. See that? So we're not done, but we've achieved something. We've managed to rewrite our whole integral from an integral in terms of x to a simpler integral in terms of u. So we now get 5u to the power of 5 all over 5. I'm just using the power rule, plus c. So this gives us 5, no, this gives us just u to the power of 5 plus c. But remember our u. Remember that our u is x squared plus 1. So we have that our final answer is x squared plus 1 to the power of 5 plus c. Okay, that is U substitution. All right, let's try another problem. Let's try something that has trig in it. Okay, how about we try number 2, integral sine of 3x dx. Here again, it's quite easy to choose your u. Choose your u as 3x. This means that du dx is equal to 3, and this means that dx is equal to 3 du. So our original integral becomes integral sine of u times 3 du. Can factor out the 3, you're left with sine u du. This now becomes 3. The antiderivative of sine u is negative cosine u, so this is negative 3 cosine u plus c. But this, we need to write the answer in terms of so let me see, maybe did we make any mistake? Actually we did. Yes, something wasn't. So we have du dx is 3. Dx should be du over 3. Yes. So it should be du over 3. So that this is 1/3. 1/3 over here. And this is 1/3. And this is 1/3. All right, so this just means that our final answer is negative 1/3 cosine of 3x plus c. Okay. All right. Now, I would like you to try one on your own, and I'll tell you the answer. This is, let's call it number 3. Integral x to the power of 5 cosine of x to the power of 6 plus 2 dx. All right. I want you to try choose your u. Let your u be x to the power of 6 plus 2. So at the end, if you do it well, your answer is going to be 1/6 sine of x to the power of 6 plus 2 plus c. So that's what your answer is going to be. All right, let's keep going. Now, let's try another one. Let's try x all over square root of 1 minus 4x squared. Okay, so here again, let's choose a u. I'm going to choose my u as 1 minus 4x squared. So at this point in time, I know there is a question on your mind. You're probably asking, how do you choose the u? All right, after this problem, I'm going to kind of give you a rule of thumb on how to choose your u. All right, so u here, the next thing you do is you find the derivative du dx, which is negative 8x, right? And then you solve for dx. I want to move this a little bit further away. So that dx is equal to negative du over 8x. All right, so we come back here, we rewrite everything in terms of u. So this becomes, so we have a dx here, this becomes integral, all right, x over square root of u times negative du over 8x. All right, so this is now, you can factor out the negative 1/8, integral, because these x's are going to cancel out, this and that cancel out, you're left with 1 over square root of u du. But now let's rewrite the 1 over square root of u du as u to the power of negative 1/2 du. So this becomes negative 1 over 8. If we add 1 to the exponent, we get u to the power of 1/2, and then we divide by 1/2. Okay, so this is going to give us negative 1 over 4 u to the power of 1/2 plus c. This is plus c over here. So by u, what's u? U is 1 minus 4x squared, so we have negative 1 over 4. 1 minus 4x squared to the power of 1/2 plus c. Or you can write it as negative 1 over 4 square root of 1 minus 4x squared plus c. All right, let's look at the problems we've looked at so far. There is a rule of thumb on how to choose your u. Choose u in such a way that when you finish taking the derivative of u, a factor of the derivative is going to be sitting outside or sitting somewhere inside the integral. So now notice, you want to notice in this particular problem, the first one, let's note that the derivative of 2x, sorry, the derivative of x squared plus 1 is 2x, right? 2x and 10x, the x's are going to cancel out, just leaving a constant, right? So just note you have this 2x, right? This is a constant multiple of 10x. So that's how you choose your du. you look at the u. When you take the derivative of u, do you have something, a multiple of that derivative, somewhere inside the integral so that they can cancel out? Again, let's look at this. 3x over here. Sorry, I erased my 3. Go back. Put my 3 originally in green. If you look at the 3x, when you take the derivative of 3x, this is 3. And what do you have over here? You have 1 sitting outside here, right? So this 3 over here, think about it as a constant multiple of 1. All right, let's look at this now. If you take the derivative of x to the power of 6, you get 6x to the power of 5. Take the derivative of x to the power of 6 plus 2, you get 6x to the power of 5. And you have x to the power of 5 sitting outside here, which is a constant multiple of 6x to the power of 5. Now let's look at this. Take the derivative. What do you get? You get negative 8x. And then you have x over here. So this is a constant multiple of x. So that's how you choose your u. All right, how are we doing with time? So all right, I will pause and then do a second part to this video. So this is just 5 5, not 7 1. But before I go, I would like to give you a problem to think about. How about, let's call this number 5. Number 5, I want you to try the integral x square root of x plus 1 dx. Now, I gave you my rule of thumb, but my hint for this is that the rule of thumb doesn't apply here. Sorry. So rules are meant to be broken. So my hint here is to start by choosing u as if you let u be equal to x plus 1, and then you go from there. All right, I'm not going to tell you the answer to this one. I told you the answer to number 3. See you on the next one.